Welcome, everyone. My name is Jerry Bowers, and I am the Director of Development and Public Affairs here at the MDI Biological Laboratory. We're thrilled to have everyone with us this afternoon. It is my pleasure to welcome our speaker this evening, Dr. James Schafer, who is an Associate Professor of History at the University of Houston. And tonight he's going to help us sort of place the SARS-CoV-2 pandemic in a historical context. But really, the secret reason why we're so excited to welcome James back to the MDIBL Science Cafe stage is that he was a student with us here in 1995 when he was an undergraduate. So we're super excited to welcome him back. He tells me that he's been back to Maine a few times since he was here as an undergraduate, and we're just thrilled to be able to share him with you all, because I think his topic tonight is certainly a very timely one as we all kind of begin to struggle to comprehend this past year and all that we've been through as a society. And so I'm super excited. And James, we are looking forward to your presentation. So thank you again for being here with us this evening. And I'm going to just turn it over to you, and we look forward to hearing your remarks.
Well, thank you very much for the introduction, Jerry. I also want to thank Emily Burke and Pip Hansen for helping to make this possible. And I think Dave Dawson a little bit behind the scenes as well. So it's an honor to be here. I want to thank you as well for welcoming a social scientist and a humanist scholar to this Science Cafe. I gather this is not unprecedented in MDIBL Science Cafe history, but maybe the humanist part might be a little bit groundbreaking. So, but as Jerry mentioned, my presence here is not as out of the ordinary as it might seem. I did work in Dave Dawson's laboratory for 2 years, actually, while I was an undergraduate at the University of Michigan, from the summer after my sophomore year to the summer after my senior year. And in the middle of that, I accompanied Dave to MDIBL in the summer of 1995. And there were many things I enjoyed about my undergraduate education in the sciences, but probably at the top of it was that visit to MDIBL in summer of 1995. So, what I'm going to do for today is first kind of introduce the history of medicine as a discipline, given that this might be one of the first, if not the first, history of medicine talks in this series. And I'll do that by way of a little bit of autobiography, talking a little bit about how I came into the history of medicine, talk a little bit about my research interests and teaching interests, and especially as they've turned recently to the history of epidemics. And then we'll dive into the bulk of the talk, where I'll kind of lay out two different ways that historians think about, write about, do research on the history of epidemics. One is more social science, and the other is more kind of humanistic exploration of the history of epidemics. We'll see how far we get with that. We may only have time to get through the demographic history portion of the talk. If there's time, I will talk a bit about the social history of epidemics and a little bit about how historians have functioned at times in the last year as policy advocates, using their historical research to shed light on some of the problems of the current epidemic, and especially the political response to it. So without further ado, let me advance the slides. Here is a blast from the past. This is Dave Dawson. Many of you will recognize in the center of the picture. Seated there. I'm not really sure who that is, but I'm told it's me, age 21. I had two coworkers in the lab with Dave Dawson that summer. I won't mention them just because I'm not sure about privacy issues, so I won't name them. But we were all together in the laboratory that summer. Of course, the real star here is in the background, the gorgeous view that you can't quite see because of the light setting, but Salisbury Cove in the background. And then the other star in this picture is in the foreground, the giant bottle of frog ringers, which was the main solution that we used to perfuse, or to the sort of extracellular bath around Xenopus levis oocytes, which was the main expression system that the Dawson Laboratory was using at MDIBL at that time anyways. And essentially the oocytes would be extracted from Xenopus levis and then injected with RNA, which would then be expressed as protein in the membrane. And the main protein that the Dawson lab was interested in was cystic fibrosis transmembrane conductance regulator, or CFTR. So that's what we were doing in the laboratory that summer. After I returned from MDI I got very interested in history courses. I finished out my cell and molecular biology major, wasn't sure what I wanted to do at that point. And I worked as a research technician for a couple of years after undergraduate before deciding to go to graduate school in the history of medicine, which is a specialty of history. You know, history is like any field that has specialties within it: labor history, women's history, economic history, et cetera, et cetera. History of medicine is one of those specialties. And there are a few specialty programs where you actually get your degree in history of medicine sprinkled around the country. So essentially, I traded the laboratory for the library and archive, and I changed the scale of my research from the cellular and molecular to the organismal and population levels. All right, so I want to talk a little bit about my research interests before I dive into putting SARS-CoV-2 in historical perspective. So in graduate school, and really a little bit in some of my coursework in my senior year of undergraduate, I became very interested in trying to understand the history of the US healthcare system. And one of the big questions that historians of medicine ask, also political historians, policy historians, is why does the United States have such an expensive, inefficient, and unjust healthcare system? This is a huge question, right? I mean, you can attack it from many different angles. You can write about it in overview. When I was in graduate school and the project that I worked on for my dissertation, and that became my first book that you see here on the left, I was focused more on doing a case study of this bigger question. And essentially, what I decided to do in order to attack this big question, or to participate in answering it collectively, was to look at the business of medicine in the United States, and in particular, when some of the characteristics of our healthcare system today acquired their telltale features. And many of those features began to emerge by the early 20th century. That's when we really see costs starting to climb in the American healthcare system, and we start to see early healthcare economists write about the unaffordability of healthcare in the United States. And so I decided to focus my case study on the early 20th century. At that time, just like today, the number one most expensive part or the number one expense for patients was hospital care. Right behind it was care received in a doctor's office. So I wanted to ask the question of, how were private medical practices organized? What was the business of private medical practice like in the early 20th century? And one of the conclusions I came to in this case study, where I looked at private practices in one of the biggest cities in the US at the time, Philadelphia, and looked at them longitudinally and how they changed over time, how they were distributed around the city, also what kinds of factors doctors considered when deciding where to locate their practice and how to run it. One of the conclusions I came to is that career decisions that doctors made, such as about whether to specialize their practice, about whether to associate with a hospital or a medical school, were in large part questions that were influenced by their private practice, by business decisions about profitability, about where they wanted to be in terms of their practice in 10 years' time, about what kinds of patients they wanted to see in their practice. And so a lot of historians have written about basically how medicine changed at the turn of the 20th century, and focused a lot on questions about professionalization, the passage of licensing laws, the growing regulation in the medical marketplace, et cetera. And I came at it from a slightly different angle, finding that a lot of these professional decisions, while important to doctors at the time, really what was on the foremost of their mind was their private practice. And that perspective shaped a lot of the career decisions they made, such as whether to become a specialist or not. Second kind of conclusion was that specialization, which is this broader phenomenon in medicine over the course of the 20th century, whereby doctors increasingly limited their practices to particular medical specialties, and sooner after graduating from medical school than ever before. One of the findings was that specialization was as much a decision about intellectual preference and aptitude as it was also about business and the business of private medical practice. And specialization offered one kind of service differentiation in the medical marketplace at that time, and that this is an important perspective to think about in terms of understanding the origins of specialization and high-cost specialty care in the present day. And then kind of the final conclusion of that project was that these market incentives in private medical practice led to a very unequitable distribution of private medical care over the city of Philadelphia. And in particular, the poorest neighborhoods and African-American neighborhoods had the fewest doctors' offices because that was where it was most difficult to make a lot of profit in medicine. And that this profit motive in the practice of medicine is part of what led to the inequitable distribution of medical services in the marketplace that we have today. Another project, one that I'm working on right now, relates to the big question of how is the relationship between the state, so think our governments, state, national level, how has the relationship between the states, the healthcare professions, and the public changed over time? And the project I'm working on right now is examining how mobilization for war, in particular the First World War, changed that relationship between those three players, between the state, between healthcare professions, and the public. And so I'm doing a case study in particular of the mobilization of American physicians for the First World War. This is not something that's typically done in the present day. The ways in which the armed forces are staffed with physicians is a bit different in terms of how they're recruited. There's much more of a standing, devoted physician workforce for the armed forces today, unlike in the early 20th century, where physicians who were recruited to care for soldiers, both in military training camps and overseas during World War I, were recruited from civilian doctors. And during the course of the war, 22% of American physicians actually ended up volunteering for military medical service, sometimes for a year, sometimes it was 2 or more years. It took a long time to demobilize after the war. So this was a kind of generational experience in the practice of medicine in the early 20th century. And one of the things that mobilization did, which was organized and run by the American Medical Association in consultation with the War Departments and the Council of National Defense, basically some of the organizations in American government that were charged with mobilizing for war. One of the things that medical mobilization did is it promoted physicians as kind of servants of the state during the First World War. Which was really an unprecedented war in American history in terms of the number of soldiers drafted or who volunteered for war, several million men in that war. So this was kind of a good PR for the American medical profession and for doctors in particular during the war, that so many set aside their private practices and went into uniform to help the United States. But one of the things I'm finding in this project that will become eventually, knock on wood, my second book, is that personal business interests of doctors that related to their private medical practice often conflicted with their sense of duty or the kind of pressure they faced to go into uniform during the war. But anyways, this is all related to the big question of how has this relationship changed over time between the state, healthcare professions, and the public. The final project I want to talk about by way of this autobiographical introduction to the history of medicine and the kinds of questions that historians like me ask is what are the deeper causes and broader effects of epidemics in history? And this is obviously a question that has come to the fore again with our latest plague in world history and human history. As part of this project, I guest edited a volume that's just come out now, a special issue, the very end of 2020, of the Bulletin of the History of Medicine called Reimagining Epidemics. In this issue, this special issue, we revisit a classic article about the kind of response we see in history to epidemics that was authored by Charles Rosenberg for a long time at the University of Pennsylvania and before he retired at Harvard. In a classic article written in 1989 about HIV and AIDS, he laid out a kind of schematic for how societies respond to epidemics. And essentially what he highlighted were a number of social roles that come to the fore during the course of an epidemic. And I'll talk about those a bit later in the talk. But in this special issue, I, with the regular editors of the Bulletin, solicited, not only republished this essay, but also solicited the input and critique of a variety of scholars who have written since Rosenberg's original article came out in 1989, who've written about epidemics in the last 30 plus years, to revisit his article and talk about the ways in which it stands up, or in other ways in which more recent scholarship has called his model of epidemic response into question. And out of this special issue, one of the lessons is that there's not a one-size-fits-all model for understanding how societies respond to epidemics, that the particular characteristics of a society greatly shape the effects of the epidemic in terms of social relations and political institutions and economic conditions. And so, this is perhaps another example of the ways in which the more precise you make a model, or the more general you make a model, maybe the less that it explains, that there's a lot of refinements that are necessary, especially in talking about epidemics as they've taken place in colonial and post-colonial nations, by contrast to wealthy industrial nations where Rosenberg's model perhaps fits a little bit better. So I'll come back to the dramaturgical model, but I just want to talk a little bit about some of the questions that I'm thinking about and doing research on right now. All right, so let me just lay out a little bit some of the main ways that historians think about and talk about epidemics. And these aren't the only two ways, but these are two of the main ways that historians think about epidemics, painting in broad strokes here. One would be kind of social science version of history, and here I'm categorizing that as demographic history of epidemics. And the other would be more the humanistic side of history that I'm calling here social history of epidemics. And just kind of looking at them side by side, the kinds of questions that are asked and answered in these two different visions of writing about the history of epidemics, we can look at side by side. On the demographic side, some of the big questions are how and why have patterns of mortality, patterns of death, mortality regimes changed over time? And this is a question that's not only of interest in the demographic history of epidemics, but is of interest to medical anthropologists, to archaeologists, to evolutionary biologists. These are questions where there's a lot of interdisciplinarity in terms of the kind of research that's out there. The sources that are used, in looking at the history of epidemics in the scale of human time and in the broad scale of human history, necessarily begins before written sources are available. So that's really the province of archaeology, paleontology, anthropology, where human remains are really kind of central until you get to written records. And even then, the kinds of records that are available to tell us about cause of death are really quite scarce in any sort of quantitative way, really until the early modern period when we start to see some of the first vital statistics collection. Before that, there's some burial records that historians are able to use, but it's dicey, and we don't really start getting decent vital statistics collection into the 17th century and later. So before that point in time, this is really kind of the province of a different kind of history. The topic I want to talk about today under this rubric of demographic history is epidemiological transitions, and I'll define that in a minute. By contrast, social history asks different sorts of questions. An example might be, what are the underlying conditions that make epidemics more likely or their effects far worse? Why do epidemics affect certain populations more than others? These are not solely determined by biology, but also by underlying conditions in the society that is affected by the epidemic. Marginalized populations, socially, economically, politically, tend to, throughout history, experience the worst of an epidemic. And these are the kinds of questions that are best answered with published sources, archival material, including personal accounts and diaries, in addition to pairing them with vital statistics to get a sense of the overall trajectory of an epidemic. And if we have time, I'll get to talking about social history of epidemics today, and I'll talk about the dramaturgical model, and how historians try to model epidemics in terms of their social, political, and economic characteristics. All right, so we'll talk about demographic history first, see how we're doing with time, and then if time permits, we can move on to social history, or else we can just focus on talking about and answering questions and talking about demographic history. All right, so just let me set the stage here in talking about the history of epidemics from a demographic perspective. One of the prevailing ideas in this kind of interdisciplinary field has been the notion that throughout most of human history, there are periods of relatively stable mortality regimes. That is to say, where the patterns of death, the kinds of things people die from, the age structure of a population have some degree of consistency. And these long eras are then separated by periods of fairly rapid change called epidemiological transitions. For those of you in evolutionary biology, the analogy would be punctuated equilibrium, this hypothesis from Stephen Jay Gould back in the day about how the pace of evolutionary change doesn't occur at a steady pace, but rather has periods of kind of long, relatively low change, and then periods of sudden change in terms of speciation and so forth. Similar idea here with epidemiological transitions, that there's long periods in human history where the mortality regime is fairly similar. Then there's a period of fairly rapid in terms of the scale of human history change, and then another period of relative homogeneity in terms of mortality regime. So the period right before the very first epidemiological transition is really the late Paleolithic. This is the period of time before about 10,000 years ago. The Paleolithic period lasted a very long time in human history. It began with the use of the first stone tools and ended with the development of agriculture about 10,000 years ago. So late Paleolithic Homo sapiens, in terms of their nutrition and habitation, they were hunter-gatherers. They didn't plant crops. They didn't stay in one place. They were mobile. The anthropological record and archaeological record suggested that they lived in kind of smallish bands that might have been familiar or slightly extra familial in their size and composition. And they moved between a wide variety of ecosystems. And what that meant in terms of demography is that there really wasn't the population density to sustain epidemics of infectious disease. That doesn't mean there weren't infectious diseases. It just means that there wasn't a sufficient population density to sustain them, or for there to be a selective pressure for pathogens to preferentially become adapted to human hosts because they were more scattered about and moving. That's not to say there weren't infectious diseases. There certainly were. It's just they didn't rise to epidemic levels because there wasn't a chance to transfer them as often between bands of late Paleolithic humans. But when they did strike, when an infectious disease did strike a band, they tended to affect the entire band and imperil the band. And so what this meant is that there was a significant influence of infectious diseases on population size. Generally speaking, until the late Paleolithic, the overall population of humanity was kept fairly low, and certainly family size and band structure were influenced by the presence of infectious disease. In terms of Paleolithic mortality, injuries were obviously a big part of the picture. Chronic diseases, generally speaking, are thought to have been less common given that they arise in middle to later life and that life expectancy was surely lower. Malnutrition was once thought to be a major source of mortality, although more recent scholarship has found that perhaps it was not as common as once previously thought, in large part because of the more diverse diet of late Paleolithic humans by contrast to early Neolithic humans. In terms of infectious diseases, I've kind of already covered this. The population density was too low to sustain epidemics or endemicity, but outbreaks certainly disrupted reproductive cycles and population growth. All right, and by the way, I've endeavored to put the source of the research that I'm summarizing or characterizing, or at least the place for you to start in your reading if you want to read more about these particular topics. So with the development of agriculture at about 10,000 years ago, and it developed at different times in different places, as you can see on this particular map here. With the development of agriculture, there began to be a significant change in the lifestyle, habitation, diets, and mortality regime of humankind, beginning about 10,000 years ago. And really it depended upon when agriculture developed where. And here you can see some of the dates around the world. There's really exciting research all the time in anthropology and archaeology, identifying new sources of agricultural revolution, previously unknown. For example, in recent last 10 to 20 years, some sites in North America, Central America, and South America have been identified, whereas previously most of the attention was focused on Mesopotamia and China. But with the development of agriculture came, like I said, a whole host of other changes. First and foremost, with the development of food surpluses, there were changes in the diversification of labor. It became possible for some people in a society to do things other than farm. And you begin to see all kinds of specialization of labor. Trade required record keeping, and you begin to see the development of language connected with development of agriculture. So there's a whole host of kind of social, political, economic changes that occurred with the dawn of agriculture. And you see, along with agriculture, obviously permanent settlement, and typically animal domestication, either for additional sources of food or else for assistance with labor in agriculture. And of course, growing population density and population growth in general. So the early Neolithic period is generally a period that has been identified as a period that experienced a kind of population boom because of the excess calories that were available through farming. In terms of how historical demographers explore the consequences of this Neolithic agricultural revolution on health, generally speaking, the main sources have been burial sites, especially multiple burials at the same site, or early cemeteries, you could call them, and comparing them before and after agriculture and looking at the age structure of the bodies that are found in cemeteries. And there's hundreds of cemeteries that have been found now from around the period of the agricultural revolution, 10,000 years ago and forwards. There's also, of course, archaeological evidence of increasing trade and population density in terms of built structures and things like that. But like I said, the main characteristics that we're concerned about here are rapid population growth and increasing population density in these agricultural communities that turn into early villages, early towns, early even cities by the time you get to about 3,000 years ago or so. Another thing to point out here, and I hope you can see the laser pointer, is that there's evidence that infant mortality began to increase significantly with the agricultural revolution. In part, that's based upon empirical data that the ratio of skeletons aged 5 to 19 relative to the age of the other skeletons in these burial sites shows an increase during this period of time. And really, the way that's been explained is that with this change in habitation, lifestyle, diet, animal domestication, et cetera, a new kind of disease environment was created wherein you have opportunities for zoonotic infections, and a lot of the most well-known infectious diseases that reach epidemic proportion in human history are thought to date back to this moment in human history: tuberculosis, smallpox, influenza, rhinoviruses, measles, et cetera. Other things related to food spoilage with early difficulties in storing not just grains, but also meat and so forth, and agricultural communities lead to other kinds of parasitic infections. In addition, habitat destruction, in particular from slash and burn farming, is now thought to have created the conditions in which mosquito vectors and also certain pathogens, such as for malaria and yellow fever, began to adapt to human hosts. At least there was a selective pressure to do that, and some of the mosquito vectors that transmit them were best suited to the hybrid and disrupted ecology of slash and burn farming. In addition, of course, sanitation with growing population density gave rise to conditions that favored waterborne diseases such as cholera, typhoid, etc. So the point is that there was a massive change in human lifestyle during the Neolithic Revolution, and this was accompanied by the first epidemiological transition in human history. And essentially, I'll come back to that slide in a moment. Essentially, infectious diseases became the main causes of death after the first epidemiological transition and in this next kind of mortality regime of humanity, which lasted all the way from the Neolithic Revolution as early as 10,000 years ago and up into the 19th century. Infectious diseases were the main causes of death. High infant mortality dominated the scene in terms of mortality regime, and that also affected the age structure of populations, with younger people being more numerous relative to older people because of this contribution of infant mortality to overall death in the population. Okay, so that's the first epidemiological transition. And just to kind of give you a sense of some of the earliest written sources that historians can use to tell us about this period of high infant mortality, high infectious and contagious diseases in the mortality regime, date back to some of the first vital statistics collection with the London Bills of Mortality, as they were called. These were collected weekly in London, I think dating back into the early 17th century, maybe a little bit before. And they were actually gathered from burial records of the Anglican Church around the city of London. And every week they would compile, the city of London, this list of causes of death. And on the left, you can see one from early April of 1665. And then on the right, you can see one from August. Looking at these categories on the left, the first thing that leaps out, I think, to our modern eyes is how different the disease categories were then. This is long before the International Classification of Diseases, needless to say. And a lot of the people who were making determination of cause of death were not medical professionals at all. They were often people who were wards of the parish, who would be the ones who went around and collected the body and maybe got a little bit of testimony from who died and from what. Nevertheless, historians can use some of these things to think about what was the relative contribution of infectious and contagious diseases to mortality in a big city like London in the early modern period. And even though some of the things may not map onto our present categories, such as King's Evil, such as French pox, or even WINS, which is presumably some sort of gastrointestinal disorder. What you can see is you could, if if push came to shove, you could lump these into probably chronic non-infectious versus infectious disease versus accident or injury or things like that. One of the things that this early record keeping, this early vital statistics collection was geared towards was to identify when plague was breaking out. And here you can see this is right in the midst of the last great London plague in 1665, when the city was absolutely paralyzed by plague. We have a lot of other kinds of documents from this time period. Daniel Defoe, Journal of the Plague Year, was written in a kind of semi-fictional account of this outbreak, among many others. But the point is that you can see a huge contribution of infectious and contagious diseases continue well through the early modern period in Europe. The picture begins to change by the mid to late 19th century, and I'll use the example here of the United States. Here you can see a graph showing the crude death rate. It's crude because it's not age adjusted. The crude death rates, that's basically the number of deaths per 1,000 population per annum. And in blue, you can see the data for the state of Massachusetts, which had the earliest state level data in the US. After 1900, the United States began endeavoring to collect national data on crude death rate. You can basically see a decline from about 20 deaths per 1,000 each year to something approaching 10. Our crude death rate is below 10 in the present day. This huge spike here coincides with the influenza pandemic of 1918, when at most recent counts, about 675,000 Americans died during that epidemic, mostly in the fall of 1918 in a handful of weeks when the flu absolutely ravaged the United States. But crude death rates begin to start to decline in the late 19th century, and a big part of that picture is actually declining infant mortality. Here again, this is from 1855 to 1970. You can see infant mortality rates expressed as number of children dying in their first year of life per 1,000 born. And Massachusetts, again, is in blue, the United States in red. And you can see that at its worst in the late 19th century, Massachusetts had 160 children dying in their first year of life out of 1,000, which is just staggering. That's 1 in 6, 16%. The United States, once they started keeping track, showed a similar trend. And thankfully, there was a tremendous downward trend in infant mortality in the first half of the 20th century. Today, we're actually less than 10 children dying in their first year of life in the United States. These patterns of declining crude death rates, especially driven by declining infant mortality, were not unique to the United States. They were found in other wealthy industrial nations in Europe, also in the Pacific Rim. You also see, well, I'll come back to that in just a moment, and let me just finish characterizing the second epidemiological transition. Just to kind of emphasize how much infant mortality contributed to the mortality regime. If we compare 1789, when this particular insurance company in the early United States collected mortality data and created a kind of life table of how much life you could expect if you reached different ages in your life. So at 0 would be life expectancy at birth, was something like 29 years only in 1789. But if you made it to your 5th birthday, you could expect to live into your mid-40s. So here you can really see the contribution of infant mortality, because the more you make it through your childhood years, the more life you could expect. And so, if you hit age 40, you could expect to live into your 60s, right? It's not that there weren't old people around in 1789, it's just that infant mortality really changed the age distribution. By contrast, if we look at more recent data, this just emphasizes how little infant mortality contributes to total mortality today. Your life expectancy at age 5 is about what it is at age 0, because thankfully so few children die in their first years of life in the United States. The final kind of key feature of this massive change in mortality regime at the end of the 19th, beginning of the 20th century, we can also see in cause of death. If we compare cause of death data 1900 to 2007, what you can see is, basically a dropping off of infectious and contagious diseases out of the top 10, or at least in the top positions of the top 10 and further down the list. In the present day, at least pre-COVID, in wealthy industrial nations, this ordering is fairly consistent. You see heart disease number 1, cancers lumped all together as number 2, and then stroke and associated cerebrovascular diseases as a distant third. And you really have to get down pretty far before you get to an infectious disease. So these are really the features of the second epidemiological transition: declining crude death rate, driven in large part by declining infant mortality, a change in major causes of death away from infectious diseases and toward chronic diseases such as heart disease and cancer. So what are the causes? Well, obviously, a higher standard of living is one that a lot of scholars have pointed to over the years, and I'll go for about 5 more minutes before pausing, Jerry. So higher standard of living, and this is something that one of the earliest demographers who pointed to this second epidemiological transition focused a lot on, last name McEwen, who looked mostly at England and Wales. He argued that really a lot of this change was driven by growing wages for the working class, better shelter, better clothing, better standard of living, less food insecurity. Other changes that were obviously important as well were better public health infrastructure, in particular water filtration and sanitary sewers. There's been a lot of really great work on the United States by Gretchen Condren, who is a demographer at Temple University. Going hand in hand with that would be personal hygiene education, and also milk inspection was another big factor in reducing infant mortality. Better preventive medicine, obviously, once immunizations became available, they play obviously a very important role, but at least when the second epidemiological transition was happening most rapidly, there was really just smallpox immunization. So really the preventive medicine contribution is more in terms of well baby visits and checkups. What played much less of a role, surprisingly, is actually curative medicine. There were very few targeted treatments of infectious diseases in the late 19th century. We do see a handful of them being developed, such as diphtheria antitoxin starting to play a role in the 1890s. But we don't really get to sulfa drugs and antibiotics until the middle of the 20th century, after most of the mortality declines have already occurred. And this is something that's obviously this group in particular, but also just in general as a society, we're very invested in the importance of high-tech medicine. And one of the lessons, at least from history, about the second epidemiological transition is that a lot of mortality gains were made before targeted treatments were actually available to people. It was more about better lifestyle, better public health, better preventive medicine. All right, I'm going to skip a couple of slides here. I apologize for that, just because I do want to get to the final epidemiological transition. So I'll skip this slide and this slide, but if you want to go back on YouTube and look at them, they're basically just emphasizing that there was, despite the second epidemiological transition, there was still a considerable amount of health inequality, not only in the United States, but also internationally, suggesting, or not just suggesting, but demonstrating that the second epidemiological transition was not yet complete. Many countries still had very high contributions of infectious diseases. Here, for example, in 2016, using WHO data, if you look at the top 10 causes of death in low-income countries, you'll see mostly infectious diseases there, whereas in high-income countries, really it's dominated by chronic diseases. Again, emphasizing that not every country made it through this second epidemiological transition. Some countries still have very high mortality burdens from infectious disease, high infant mortality. So the question is whether we're in a third epidemiological transition, and that's really where the SARS-CoV-2 connection comes in. I'll make this the last slide, I guess, for now. So back in 1992, as part of the Institute of Medicine, which is now the National Academy of Medicine, Joshua Lederberg and some other editors put together a volume talking about emerging infections worldwide. And they were particularly concerned about growing antibiotic resistance, both from misuse and overuse of antibiotics, and also just from selective pressure on pathogens through extensive use of antibiotics. But they also pointed to the emergence of a variety of new zoonotic infections that had already popped up by 1992. And of course, we've added a number more in recent years, most notably coronaviruses and of course, SARS-CoV-2. And this kind of argument they were making was kind of sounding the alarm bell that there's something going on where we may be entering another period of rapid change in our mortality regime, losing some of the gains that we had enjoyed during the second epidemiological transition, at least in wealthy industrial nations. And in the field of medical anthropology, a similar argument was being made, most notably by Armalagos and Harper, who basically put out the idea that we're in the middle of a third epidemiological transition where antibiotic resistance is making it so that previously controlled infectious diseases are making a return. Think MRSA, think multi-drug resistant tuberculosis. In addition, they point to the emergence of a variety of new zoonotic infections. And we can all make our own list here, but SARS-CoV-2 will certainly be on it. And they point to a lot of factors that are driving this possible third epidemiological transition, some having to do with rapid transport and global trade and all of this, but others having to do more with habitat destruction and urban sprawl and the increasing contact between humans and non-human animal populations, making crossover events more likely. Another culprit they point to is the industrial production of meat and animal products, leading to large, obviously unnatural populations of animals that are in very poor health, and where pathogens can spread rapidly and where humans are in contact with them. And we can all point to our example of choice. Obviously, the story about mink populations in Denmark and elsewhere is a big story in terms of SARS-CoV-2 finding a home in other non-human animal populations beyond just the ones we already knew about, possibly originating in bats, maybe through an intermediate species coming to humans. So as predicted, I didn't make it further than the demographic history of epidemics. I'm actually a social historian, so I would have been perfectly happy to talk about the social history of epidemics, but I better stop there. Thank you for your indulgence. Once I get going, I have a hard time stopping here, but we'll just limit our discussion, I guess, to talking about the demographic history of epidemics and how historians think about it.
This is fascinating. I know that we put a lot of pressure on you to go through this whole historical perspective in 30 minutes, but it really is fascinating to look at these different periods in our history and try to then kind of correlate that with some of what we're seeing today. I know that we have some questions from the audience, and I just want to open it up a bit and encourage folks to put any questions that they have in the chat. One of the ones, and you've touched on this, I think, in that last slide when we talk about some of the causes for maybe this transition into another phase. And this one question is, if the growing gap between rich and poor is not addressed soon, do you see a world where infectious diseases could start to adversely affect lower socioeconomic populations? I.e., is there a chance we could start going backwards?
Yeah, it's a great question. Right before I answer it, let me just say, I can hang out past 5. So if people want to stick around and keep talking, as long as the organizers are willing, I'm game. So I hope that allows us to get a few more questions in, despite me running along a little bit. So the question is, if widespread endemic poverty isn't addressed, are we going to see a return to previous conditions? And it's kind of two answers to that question, both yes, but number one, I didn't have a chance to get to this, but even in countries that underwent the second epidemiological transition, you still see inequality in terms of mortality data. So in the United States, for example, in the present day, infant mortality rates are twice as high, a little bit more than twice as high for African-American babies by comparison to white babies in the US. Now, historically speaking, they're much less than they were when they were 160 per 1,000. African-American infant mortality is around 11 to 12 right now, and white is around 5-ish, 5 to 6. And that's on one of the slides I had to skip over. So the point is there that even in countries that had the second epidemiological transition, it was still not enjoyed equally by everyone in the country. And not just along racial lines in a place like the United States, but also along class lines. So there's been all kinds of studies published in JAMA, in the New England Journal of Medicine, basically correlating income to life expectancy. And that gap can get to be as much as 8 to 10 years from the lowest earners to the highest earners in terms of life expectancy. So first of all, inequality along poverty lines and lines of oppression, we see even in countries that underwent the second epidemiological transition. Now, in countries that didn't fully finish or start very well the second epidemiological transition, absolutely there's been a backsliding driven in large part by poverty, lack of ability to spend on healthcare infrastructure, healthcare personnel. That was particularly the case with the emergence of HIV and AIDS in the 1980s, and especially the globalization of that pandemic. Sub-Saharan Africa, since the late 1980s, has really been the center of that epidemic, even though it's largely been forgotten about by people outside of public health and medicine in places like North America and Western Europe. There, you still have some countries in the very southernmost portion of Africa have adult prevalence rates north of 10%. But there's been a number of studies in public health over the decades since HIV/AIDS emerged that show a decline in life expectancy as a result of HIV and AIDS in countries that had been making gains, had been undergoing the early stages of that second epidemiological transition. Obviously, SARS-CoV-2 is going to change the picture even further. even looking at a place like the United States, which spends the most per capita of any country in the world on health, SARS-CoV-2 leapt to be the third leading cause of death after heart disease and cancer last year, and who knows where it's going to be for 2021. So, you know, and then if we drill down with SARS-CoV-2, you know, it's widely been reported upon that mortality rates are higher, serious cases are higher among communities of color and poor communities in the United States. So absolutely, poverty, this is where the social history comes into the demographic history. Poverty is one of the underlying conditions that exacerbates an epidemic, and the poorest and most marginalized feel the fullest effects of epidemics, and that hasn't changed, unfortunately.
Mm. So a somewhat related question has come in, you know, just talking about what role do underdeveloped countries play in these transitions on a global scale? For example, rates of polio increasing in Afghanistan and Pakistan, which are both underdeveloped and war-torn. Could this eventually affect developed countries like the US?
Absolutely. Now, polio is a little different because there's obviously a vaccine there. A little bit of context, only one disease, infectious disease, has been eradicated through vaccination. That was smallpox in the 1970s. Polio has been a hope for a couple of decades now because there's been a vaccine for quite some time. And also because of the nature of the disease, there's not really an animal vector for it, right? It's directly transmitted from human to human, which makes it easier to control with vaccine than, say, something that has an animal vector like malaria or yellow fever, where you have like a third species to deal with beyond the pathogen and the host. But absolutely, like there's many arguments for why an eradication campaign for polio is important. Obviously, the moral argument is the most important one. It's wrong that people are still dying of polio when there's been a vaccine for a half century now, more than a half century. You know, the other reason, of course, is that it's in the self-interest of donor nations to be concerned about epidemics of infectious disease elsewhere, both for the moral reasons and also for the self-interest argument that an epidemic in one country can easily become an epidemic in a neighboring country or even further afield very rapidly. Polio might be a little bit different just because there is still vaccination, but certainly other diseases that aren't well controlled run the risk of being anywhere in a short period of time.
Fascinating. So one more question here. Are you aware of any research about climate change looking at the possibility in moving into a third epidemiological age as an inevitability due to climate dislocation?
Absolutely. There's definitely a lot of research on climate change and its contribution to the changing mortality regime and possibly a third epidemiological transition. Really, one of the main areas of action has been in how climate change affects the habitat of vector species, and in particular, mosquito vectors, so Aedes aegypti, and then various anopheline vectors in the case of malaria. And, you know, basically the hypothesis, or at least based on some early observation, is that the range of these mosquito vectors is moving farther from the equator with climate change. That as long as the right moisture conditions are there, the right temperature is now there for these vectors to increase their range, and where the vectors go, so goes the pathogen, or at least that's the idea. And so there was a lot of concern about this with Zika, which broke out back with the Olympics in Brazil. And then quickly there were cases found even from people who haven't traveled to Brazil in places around the Caribbean, a couple outbreaks in the United States. There's even been cases reported of dengue, which is usually associated with the tropics in the United States along the Gulf Coast. Minor at this point, but you know, it doesn't take much of a science fiction imagination to imagine how this could worsen with time, or at least that's a concern. So it's mostly about the vectors, as I understand it, when it comes to global warming.
Fascinating. We have another comment and question. I once read that an early societal response to epidemics was the Indian establishment of the caste system. Do you have any opinion on this? Is this a generally accepted argument within the history of medicine? Unfortunately, I can't cite the source.
Thank you for the question. I have to plead ignorance there. I had thought that the caste system dated back, though, to foundational religious texts in the Indian subcontinent, where at least several different castes were differentiated in some of the foundational religious texts there. But I don't know the contribution more recently in terms of epidemics and caste, but there is research on that. Pratik Chakrabarty has written a lot about epidemics on the Indian subcontinent, as has Mark Harrison, if you're looking for more to read on those particular topics. And certainly you could look at the footnotes there and they could cite more detailed literature.
That's great. So compare the political response in 1918 to today. We have another 14 minutes. So we can
yeah, I mean, that's the one that has obviously been in the news a lot. And it makes sense because up until now, that was the worst epidemic in American history. There were other diseases that killed far more people, that were more endemic, such as tuberculosis, such as smallpox earlier in American history. But the 1918 influenza pandemic was certainly the worst as an epidemic straight. And so in terms of the political response, it's a bit apples and oranges, right? We can see certain themes that resonate. There was plenty of denialism, plenty of resistance to mask wearing in 1918. There was just a wide array of responses by cities in terms of whether schools were closed, public gatherings were banned. There's been some really great historical research by Howard Markel, who's both an MD and a Ph.D. in history of medicine at the University of Michigan. And he's written, he's basically studied in a social scientific way, the length of limiting of public gatherings in 1918 and related that to peak mortality, total mortality during the 1918 epidemic. And his research actually came to the fore again late March last year, and he actually published a number of op-eds reminding us of the importance of non-pharmaceutical interventions in preventing the spread of a new infectious disease for which we have no treatment, because as his research had shown in 1918, they made a huge difference. The cities that closed earliest and longest had not only lower peak mortality, but lower total mortality over the course of the epidemic. Cities that closed but reopened very quickly, they experienced a second peak of mortality, and their total mortality was greater, statistically significantly greater than cities that stayed closed longer in 1918. So Markel wrote a number of op-eds back in March of 2020, urging for schools to be closed, which they weren't at the very beginning, and pointing to this research as evidence that it can work, and in some cities it did work in 1918. But what's really kind of different in 2020 to now compared to 1918 is the media environment that we live in, right? 1918 was pre-radio. Film and newspapers were the main sources of news. The other thing that was happening in 1918, of course, was the First World War, and the United States was in the midst of this rapid mobilization. There was extensive government influence on the media. There were laws curtailing First Amendment rights in 1918 and even back to 1917 as the war was starting for the US anyways. So there was tremendous pressure not to publish negative views in newspapers at that time. And in particular, as they pertain to the war. So all kinds of political dissent was stifled by the Espionage Act and Sedition Acts during the war. And so what this meant was that there was hesitation to publish articles about how bad the epidemic was. That has a little bit of a ring of similarity to the present day. Our media environment is a little bit different, obviously, but there's definitely the presence of propaganda in the present day, as we certainly saw. I think it's fair to say, without seeming partisan, it's fair to say that in the previous presidential administration in the United States, there was significant effort to spin the epidemic, to deny its severity early on, to deny that it was spreading, to deny that even people who didn't have comorbidities could have a serious case, to deny that it was still going on, to deny there was a second peak, a third peak. et cetera. So that part feels a bit similar. What I guess is really missing from 1918 by comparison to today is a sense that we're all in it together. Now, that was partly driven by the war in 1918 and this, government propaganda to convince people of the necessity and urgency and importance of the war. So there were pressures to unify people that were pre-existing in 1918. But today, the way in which the epidemic became politicized has in the United States has been deeply troubling to so many people, especially to historians, because that hasn't always been the case in epidemic history. Epidemics are moments of reflection and of thinking about the performance of leaders and so forth, but this kind of turning against one another that's been so unfortunately on full display in the United States is actually not something that we see typically with an epidemic. Sure, there's instances, but there's also plenty of examples of people pulling together. And even in this particular epidemic, if we look at other settings worldwide, the kinds of responses, not just public health, but social and political and economic, have just been so different. Which really just underscores the ways in which the local context of the epidemic really matters for the experience of the epidemic and also for the demography of it.
Amazing. So I have to ask you, as a historian, it must feel a little surreal to be sort of living in this period of history as we go through this. Have you had kind of thoughts about sort of, what does it look like looking back on this period in our history, say 50, 100 years from now? What do you think will really stand out?
Absolutely. I think about it every day. I can't not think about it.
Yeah, right.
Sometimes I wish I could. So kind of autobiographical response to that. So I regularly teach at the University of Houston a course on the history of epidemics, right? And I happened to be teaching it in spring of 2020 when the epidemic broke out. And, when campus closed and we switched to online, we kept revisiting some of the early readings that we had done from earlier in the semester about models of epidemic response and so forth, and trying to figure out, how closely does this resemble other things that we've read about in history. And the parallels, the themes that pop up were really alarming. But also, it helped to kind of demystify what was happening, because some version of this has happened somewhere before, even if not in its entirety. Bits and pieces here and there have happened before. I even had students from previous semesters email me who had taken that class saying, "Can you believe what's happening? This is so much like, Charles Rosenberg's reading on epidemic response," which I didn't have a chance to get to today. So absolutely, it's been surreal as a historian, because even though we're trained to try to take the past on its own terms, to not project our present day values onto the past, even though we're trained not to think of history as somehow some inevitable arc of progress and that the present is some miraculous improvement upon the past, even though that's part of our training, I guess still in the back of my mind, I had hoped that we would do better than we've done. And that's been the kind of really heart-wrenching part, being a historian through this, is to see just how badly this was handled in the United States.
Mm. Well, I don't want to end on a dour note, but I think we all agree with you.
History can be a bummer.
History can be a bummer. There's still time. Maybe we can learn from our mistakes and strive to do better. But Dr. Schafer, thank you so much. This is a fascinating look at, it's really helpful to be able to take a step back and, we're sort of all still living in it. And so it is fascinating to sort of see the context. And I really appreciate your sharing that with us today. Thank you so much.
Thank you for having me.
Well, welcome. And we hope, by my count, we can bring you back for at least 2 more science cafes. So. Really, really appreciate your perspective. Thank you. And thanks to all of you for joining us. In light of kind of our look back on or providing historical context, we will have another MDI Biological Laboratory alum with us next month for our Science Cafe to take a look at regeneration in a historical context. So even though it sometimes seems like a relatively modern day phenomena, we know that even Greek mythology talked a bit about regeneration. So Dr. Chuck Dinsmore will be with us. He was here at MDIBL in the 70s doing regeneration research. And so fascinating opportunity to really talk with him about sort of the historical context, but what does the future look like for regenerative medicine? So we hope you'll all join us next month. And again, thanks so much to Dr. Schafer for joining us this evening.